Everyone in tech loves a good architecture debate, but if you've spent any time on LinkedIn or tech Twitter lately, you've probably noticed a pattern. Every single AI startup is pitching the exact same blueprint. You take a PDF, you chop it into chunks, you turn it into vectors, you throw it into a vector database, and boom, you've got an enterprise AI copilot. It looks amazing in a weekend demo. Investors throw money at it, but almost nobody is asking the one question that actually matters. What actually survives production? Here is the brutal reality. The era of embed a PDF and call it intelligence is officially dead. In the real world, enterprise buyers are stopping looking at flashy demos and starting to ask, can I trust this answer enough to bet my multi-million-dollar business on it? And more often than not, traditional vector RAG is failing the test. Today, we are looking at why the absolute hottest trend in AI, vector databases, is hitting a massive brick wall, and the secret architecture that the world's most serious AI engineering teams are actually using to replace them. Let's get into it. To understand why traditional retrieval augmented generation, or RAG, is breaking down, we have to look at its core assumption. Traditional RAG treats document chunks like independent rows in a spreadsheet. It assumes that data is atomic. It takes a 100-page document, cuts it into 512 character blocks, and uses something called Cosine similarity to find pieces of text that sound like your question. But here's the problem. Semantic similarity is not logical reasoning. When you chunk a deeply structured document, you are physically severing its topology. You are cutting the wires. Let's look at a real-world example of how this destroys an AI system. Say you're building a legal copilot. On page 2 of a contract, it says, users may terminate this agreement within 30 days. But way down on page 48, under a completely different heading, it says, termination rights are strictly excluded for enterprise agreements. If an enterprise user asks your AI, can I terminate my contract? A vector database looks for similar wording. It scores page 2 incredibly high because it explicitly talks about termination. It might completely ignore page 48 because the wording is different or it's buried deep in an appendix. The AI confidently outputs, yes, you can terminate within 30 days. Congratulations, your AI just gave illegal legal advice that could get your company sued. This is exactly why a new paradigm is emerging. We're seeing the rise of vectorless, hierarchical, and graph-based RAG systems. They aren't replacing vector DBs everywhere, but they are absolutely dominating specific areas where retrieval mistakes are expensive, and reasoning matters more than speed. Let's look at the 6 high-stakes industries where this is happening right now. As we just saw, legal documents are not independent chunks. They are complex webs of definitions, exceptions, cross-references, and nested conditions. Law requires precise logical dependency retrieval. The companies building serious legal copilots right now are moving beyond naive embeddings. They use systems that follow definitions, traverse exclusions, and preserve the exact lineage of the context. Insurance policies are basically adversarial logic trees. One clause modifies another, one exception overrides a definition, and definitions mutate globally. Traditional RAG fails here because exclusions are often miles apart from the rules they modify. Vectorless retrieval wins because it doesn't just look at keywords, it navigates the actual policy structure, traces the exception paths, and builds a bulletproof evidence chain. Because in insurance, a hallucination is a direct financial liability. In medicine, context is a matter of life and death. If a doctor asks about a drug interaction, missing a single contraindication buried on page 42 because a chunking algorithm cut it off is catastrophic. Medical AI is rapidly shifting toward graph structures, knowledge graphs, and ontology reasoning, not just vectors. Most corporate wikis, SOPs, and architecture specs are absolute garbage data-wise. They are messy, full of nested pages and diagrams. Furthermore, employees don't ask, find me semantically similar text. They ask, what policy actually applies to my specific situation right now? That requires logical reasoning, not just keyword matching. If you've used advanced coding agents lately, you know they are getting eerily good. But they aren't doing it by just embedding a GitHub repo into a vector database. Code retrieval is a dependency problem. you have to navigate call graphs, resolve symbols, and traverse abstract syntax trees, ASTs. Semantic similarity alone fails because two functions might look identical, but behave completely differently based on their context in the repository map. A single footnote in an earnings statement can completely invalidate an entire page of financial tables. Finance requires temporal relationships and tight, traceable reasoning. If an executive can't audit exactly how the AI calculated a metric, they won't use it. Now let's pause for a second, because there is a cynical trend on tech YouTube and LinkedIn where influencers love to declare that vector DBs are dead for clickbait. Let's be real, they are absolutely not dead. Vector databases are an incredible piece of engineering, and they still absolutely dominate 4 massive use cases. Massive scale semantic recall. If you need to search across 10 billion documents, customer service logs, or raw chat histories at lightning speed, ANN search in a vector DB is unmatched. Messy, unstructured data, OCR scans, Slack messages, screenshots, and messy PDFs, vector embeddings find signal in noise, recommendation systems. Fuzzy similarity is the goal for feeds and recommendations. Multimodal search, searching images with text or matching audio clips. Vectors own this space. So, what is the dirty secret of the AI industry right now? The traditional PDF to Pinecone wrapper stack is rapidly commoditizing. Anyone can build it in an afternoon using an online tutorial. The moat is completely disappearing. The next generation of AI engineering isn't bragging about what vector database they use. The real moat is being built in retrieval orchestration and data hygiene. Serious teams are focusing on 1. Intelligent ingestion, spending money on advanced layout parsers that understand tables, charts, and document hierarchies before anything gets turned into text. 2. Hybrid and graph relational architectures, using vector databases for broad brush, fast initial recall, but then passing those results to a deterministic graph traversal system to pull in the actual logical context chains. And what about massive context windows? Some people ask, why build RAG at all when models like Gemini or Claude can take 1 million tokens in a single prompt? Well, 3 reasons: cost, latency, and auditability. Shoving 1 million tokens into an LLM for every single user query is financially ruinous at scale. It takes forever to get a response back. And most importantly, if the model makes a mistake inside that massive context window, you have zero way to audit why it happened. Here is the ruthless reality check for anyone building in the AI space today. Most companies do not need a hyper-complex, over-engineered hierarchical reasoning system, but they also can't survive on naive vector search anymore. What most companies actually need is better data hygiene, proper re-ranking, metadata filtering, hybrid search, and deterministic citation validation. An architectural buzzword is not going to save a poorly designed system. The winners of the next phase of the AI boom aren't going to be the ones who build the flashiest weekend demos. They are going to be the engineers who solve the boring, unsexy problems: traceability, contextual integrity, and evidence grounding. Because at the end of the day, enterprise customers don't care about the AI magic. They care about truth. If you found this breakdown helpful, drop a comment below. Are you using pure vector RAG, or are you starting to feel the pain points of chunking? Smash the like button, subscribe for more real-world software architecture deep dives, and I'll see you in the next one.